So, naming alkanes. The first thing that will be helpful is to just know your 10 alkanes, which, methane, ethane, butane, methane, ethane, propane, butane, pentane, etc., etc., etc. You need to know up until decane. So you're going to have to remember those because those are your parent alkanes. So let's look at this, right? And we're going to go through the rules as we name these. So the first thing you want to do with alkanes is that you want to count your parent chain. And that is the longest continuous, that word continuous means so much. It's the longest continuous carbon chain. So here's what I'm going to do. I'm going to count the longest continuous carbon chain. And I could, in fact, start from anywhere. So I could start from here. And I'm going to start from here and say 1, 2, 3, 4, 5. I could also start from here. 1, 2, 3, 4, 5. All right. So I'm in a position where I could go two ways, but everyone should see that this right here will be an easier way just to, go straight across here, instead of going up and then coming down, right? Makes much more sense to stay on the flat. So you want to count your longest continuous chain. So this is 1, 2, 3, 4, 5. So your parent chain in this situation will be pentane. Yes. The second thing now you want to do is identify substituents. Substituents are basically anything that is branched off the parent chain. And so right here, there's actually a CH3 that is branched off. So as substituents, we use the suffix basically YL, right? So CH3, right, usually we'll say something along the lines of, methane, or ethane, right? But in this case, we name it using the YL, which will be methyl, right? Anytime you have a CH3, which is always implied when there's no ending, it's methyl, right? And the same thing, you could have propyl as a substituent, ethyl as a substituent, right? So again, our parent chain is pentane, her substituent is methyl, and we got to identify on what carbon it is on. Well, counting from here, this is 1, 2, so it's on carbon 2. So putting everything together, you always want to separate your numbers and words with hyphens. So this will be 2-methyl pentane. And this last part here, when you're done with your substituent, you're going to squash it together with your parent chain. Now, just a quick, reference here. I could have started here and go 1, 2, 3, 4, 5. But you always want to start from the branch. You always want to start counting from where you have the closest branch point, right? Where you have the closest substituent branched off the carbon chain. So here, 1, 2, 3, 4. The substituent doesn't come until carbon 4. Here, the substituent came at carbon 2. So just keep that in mind. How about this one? Again, nothing changes. We're going to identify the longest continuous carbon chain. And I could start from here, I could start from here, I could start from here. We're just going to make sure it's continuous. So I'm going to start from here first. Say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How about this? 1, 2, 3, 4, 5, 6. So I could start from any of these, but again, starting from this and just going right across will make our life much more easier. So again, the parent chain, we have 6 carbons. That corresponds to hexane. Right? Now we have substituents. So we actually have 2 methyls on carbon 2. So here's the rule. Anytime you have 2 of the same substituents on the same carbon, you're going to give both of them numbers. So in this case, the name for this compound will be 2, 2 dash, and here's what. We have 2 methyls. So we're going to use the prefix di to kind of imply that we have 2 methyls, just to make things a little bit more simpler. So this will be 2 dimethyl, and here's where we're going to squish everything together. Hexane. Right? Again, notice I gave each one of my substituents the number 2. So keep in mind. That, and we use prefix to kind of, simplify things if we have 2 of the same things or 3 of the same things. So if I had one more, methyl bond to this carbon, then it will be 2 dash trimethyl. All right. Let's look at the next one. How about this one? A lot of things going on here, but nothing changes. We're going to count our longest carbon chain. Longest continuous carbon chain, rather. So I could start from here, 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 here. Whichever gives me the longest, that is what I'm going to go with as my parent. So 1, 2, 3, 4, 5, 6, 7. How about this? 1, 2, 3, 4, 5, 6, 7. How about this? 1, 2, 3, 4. That won't work. How about this? 1, 2, 3, 4, 5. So as you can see, 1, 2, 3, 4, 5, 6, 7 will be my parent because that is the longest continuous carbon chain. So the parent name for 7, all right, will be heptane. Yes. Now we got to identify a substituent. Now remember, this is our carbon chain. All these are substituents. Now I can't start from here because look at it. My first branch point doesn't come until carbon 1, 2, 3. Here, my first branch point comes at carbon 2. So I'm definitely going to start counting from here. So we identified the parent chain as heptane, right? So we have 1 methyl. Well, not 1 methyl, I apologize. 2. On carbon 2, we have a methyl. So as substituents, I'm going to have 2 methyl on carbon 2. Carbon 2, 3, 4. On carbon 4, also have a methyl. So 4 methyl. Location. On carbon 5, also have a methyl. And this will be 5 methyl. All right. So all we got to do now is just put these together. Well, since the substituents are the same, we're just going to keep the numbers in order and kind of use a prefix to make things simpler for these methyls and squash everything together. So here's how it works. This is 2, 4. You always want to use comma to separate your numbers. 5 dash 1, 2, 3. We have 3 methyls, so this will be trimethyl heptane. All right, this will be my name for this compound here. Again, I could have started from here, but look, carbon 1, 2, 3. My first branch part comes at carbon 3. Carbon 4 will be my second one. Then carbon 5, 6 will be my third one. So here we went. So counting from this end, we would have went 3, 4, and 6, which is way higher than these numbers here. So you always want to make sure you get the lowest counting numbers. Look at the last one. All right. Now with halogens, you always want to, as substituents, they take on this form of O at the end. So chlorine is actually chloro as a substituent. Bromine is actually bromo as a substituent. Fluorine is actually fluoro as a substituent. Again, so nothing changes here. I'm going to count my longest continuous carbon chain. So I can start from here and say 1, 2, 3, 4, 5, 6, 7. How about this? 1, 2, 3, 4, 5, 6. That definitely would not work. So here we could clearly see that my parent chain will be heptane. Again, because there's just 1, 2, 3, 4, 5, 6, 7. All right. So how are we going to label this? Right. I could start from here. I'm going to start from here. And here's the reason why. On carbon 1, we have a bromo. Carbon 1, 2, 3. So the first substituent doesn't come until carbon 3 here. The first substituent is actually on carbon 1 here, which is bromo. So as substituents, I'm going to have 1 bromo. How about the other one? All right. So carbon 1, 2, 3, 4. So I'm going to have 4 dash chloro. All right. In carbon 5, we have a methyl group, which will be 5 dash methyl. Right. So now we have all our substituents. All we got to do now is just squash these together. Now here's the thing. You always want to arrange these in alphabetical order, right? Whenever you have different substituents, you always want to, arrange them in alphabetical order. So here's how I'm going to do this. I'm going to say 1 bromo, because B comes before C, dash 4 chloro, C comes before M, dash 5 methyl, running out of space here, heptane. And I ran out of space there, so bear with me. Right. So this will be the IUPAC name for this compound.